Hello class, in this video I'll be showing you how to find all the zeros of a polynomial function and how to rewrite a polynomial function in completely factored form. Let's begin. So we want to find all zeros of n of x and rewrite n of x in completely factored form. I'm going to start by identifying the degree of n of x because that will tell us how many zeros n of x has. The degree of n of x is 4. So by the fundamental theorem of algebra, n of x has 4 complex zeros. So I'm going to start by finding the rational zeros of n of x. And to do this, I'm just going to graph this function in Desmus. So I've gone ahead and graphed n of x in Desmus. And notice that n of x has 2 horizontal intercepts. And there are 2 rational zeros, one at -4 and one at 1/3. I'm going to use these rational zeros to find the other 2 zeros. So from Desmus, x is equal to -4 and x is equal to 1/3 are zeros. To find the other 2 zeros, I'm going to use synthetic division. I'm going to synthetic divide by -4 first. I'm going to bring down the 3. -4 times 3 is -12. -1 plus a -12 is -13. And I'm going to finish the synthetic division. And just as expected, when synthetic dividing by -4, the remainder is 0 because -4 is a 0 of n of x. Now I'm going to synthetic divide by 1/3. And I'm going to use these numbers that I highlighted in red. Bring down to 3. 3 times 1/3 is 1. And that -3 plus 1 is -12. And I'm just going to go ahead and finish the synthetic division. And again, the remainder is 0 because 1/3 is a 0 of n of x. So now we have 3, -12, and 39. These are the coefficients for the polynomial 3x squared minus 12x plus 39. And this is a factor of n of x. So what I'm going to do is I'm going to set that factor equal to 0 and solve for x. So we have 3x squared minus 12x plus 39 is equal to 0. And I'm going to divide every term by 3. So we have x squared minus 4x plus 13 is equal to 0. This trinomial does not factor, so I'm going to have to use the quadratic formula. So we have x is equal to -4 plus or minus the square root of -4 squared minus 4 times 1 times 13, all divided by 2 times 1. So now we have, after all the simplification, x is equal to 4 plus or minus the square root of -36 divided by 2. So we have x is equal to 4 plus or minus 6i divided by 2. And dividing both terms by 2, you get 2 plus or minus 3i. So the zeros of n of x are -4, 1/3, 2 minus 3i, and 2 plus 3i. And I'm going to use these zeros to completely factor n of x. So we have n of x is equal to some coefficient a times x minus -4 times x minus a 1/3 times x minus 2 minus 3i times x minus 2 plus 3i. To find a, we're going to go back to the original function. And a is going to be the leading coefficient of the polynomial, which is 3. So n of x is equal to 3 times x plus 4 times x minus 1/3 times x minus 2 plus 3i times x minus 2 minus 3i. And we are done.